Hey everyone, you ever stop and think about what's actually happening when you click a link or type in a web address? It feels instant, like magic. But today, we're going to pull back the curtain and trace that incredible, high-speed journey that happens in the blink of an eye.
So, there you are. You type in an address, you hit enter, and poof, a website appears. But what really goes on in that split second? I promise you, it's not magic, it's this complex, beautifully choreographed dance of technology. And we're going to break it all down step by step.
So the whole thing kicks off with a simple request. You can think of your computer as a customer. It needs to ask for something, in this case a web page, from another, way more powerful computer that could be anywhere in the world. This simple little conversation is the foundation of, well, the entire web. Let's make this even simpler with an analogy. Imagine your computer or your phone is the client. That's your house. The website you want to visit? That's stored on a server. Think of it as a shop. So to get anything from that shop, your house has to send it an order.
Okay, so how does your order get from your house to the shop? Well, it travels along the internet's highways using a set of rules called TCP/IP. And here's the really clever part. To make the trip super fast and reliable, your request isn't sent as one big file. Nope, it's broken down into these tiny little chunks called packets. That way, if one packet gets lost or hits a dead end, only that tiny piece needs to be resent, not the whole thing. It's a design that's all about survival, which is exactly why the internet is so resilient.
All right, so your request is broken into packets and it's ready to go. But wait, the internet is a massive, massive place with billions of servers. How in the world does your request know exactly which shop to go to? This is where the internet's brilliant addressing system comes into play. We humans, we don't use complicated map coordinates to find websites. We use a domain name, right? Like Google.com. It's the human-friendly, easy-to-remember name for the website, just like the name of a shop. It's easy for us to type and to remember. But computers, they don't speak in names. They speak in numbers. Every single server connected to the internet has its own unique label called an IP address. You can think of this as the shop's actual postal address. It's precise, it's perfect for machines, and it tells your data exactly where it needs to go. So you've got two sides of the same coin, right? The simple name that we use and this string of numbers that computers use. The absolutely crucial next step is translating one into the other. And that translator has a name. It's the Domain Name System, or DNS. Its entire job is to be the internet's gigantic global address book. When you type in a domain name, the DNS looks it up and finds the matching IP address. Simple as that.
Now, the actual lookup process is kind of like following a trail of clues. Your browser first asks a local DNS server, hey, you know where this is? If it doesn't, it asks a root server, which points it to the right server for, say, .com. That server then points it to the specific server for Google.com, which finally gives back the correct IP address. And this whole scavenger hunt, it all happens in milliseconds. It's unbelievably fast. Okay, so your browser now has the server's address. The next step is to actually strike up a conversation. But just like people, computers need a shared language and some rules so they can communicate without getting confused. This conversation follows a really simple pattern. Request, response. It's just like a phone call. The client makes a request, and the server processes it and sends back a response. The client asks, the server answers. It's the fundamental pattern for a clear two-way digital chat. And the language they use for this chat is called HTTP. Now, when the server responds, it sends a status code. And I know you've seen some of these before. 200 OK is the good one. It means success. The server is sending you the files. Then there's the dreaded 404 not found, which means the server couldn't find what you asked for. And a 503 service unavailable, that usually means the server is just overloaded or maybe down for a bit of maintenance. So, once the server gives that 200 OK and sends the website's files back in all those little packets we talked about, the final act begins. Your browser now has to take all of that raw code and turn it into the web page you actually see on your screen.
So your browser basically becomes this master builder. First, it reads all the HTML and CSS code to create a kind of blueprint. Then, it calculates the layout, figuring out the exact size and position of every single thing on the page. And finally, it paints the pixels onto your screen, bringing the whole website to life. You know, how that page gets delivered can be pretty different. A static site is like a pre-printed book on a shelf, ready to be handed to anyone who asks instantly. But a dynamic site? That's more like a custom print-on-demand book. When you request it, the server has to assemble the layout, pull content from a database, and piece it all together just for you, every single time.
This whole process is, well, it's an incredible feat of engineering, but it is not foolproof. So, what happens when one of these delicate steps breaks? The answer is something we've all experienced: downtime.
So what causes these failures? You might think it's all hackers and sophisticated cyber attacks, right? Well, according to the Uptime Institute, the two biggest culprits might actually surprise you. In recent years, about 43% of major outages were caused by simple power failures, and an incredible 40% were just due to human error, someone messing up. And the stakes for failure are ridiculously high. We have zero patience online, don't we? Research shows that most of us will just give up and leave a site if it doesn't load in just 3 seconds. That is a tiny, tiny window where everything has to work perfectly.
And server overloads are a huge threat. I mean, check this out. During the 2022 Super Bowl, Coinbase ran this clever ad with a QR code. It got scanned by 20 million people in a single minute. That massive, unexpected wave of traffic was just too much, and their site crashed for an hour.
The financial cost of this stuff can be astronomical. Back in 2017, a huge chunk of the internet just vanished when Amazon's S3 cloud service had an outage. And the cause? A single team member executed the wrong command during a routine fix. The estimated cost of that one little mistake was over $150 million.
Which brings us to a final thought. From ordering our groceries to running global economies, our reliance on this invisible system is just growing every single day. So as more and more of our world moves online, it really makes you wonder, what does downtime truly cost us, beyond just the dollars and cents?